Okay, we'll get started and we'll assume the audio is working. Okay, welcome. I'm doing a talk on the Dunning-Kruger effect. Real quick, who here has heard of this effect before? All right, so like 20 some years ago, quite that long ago, there's a paper that came out called Unskilled and Unaware of It, How Difficult to Recognize One's Own Competence Lead to Inflated Self-Assessment. So this was a scientific paper with studies conducted. Pop psychology got a hold of it, and they turned it uh, little infographic. And it's pretty accurate. Caleb, very, very choppy. Test. That's pretty clear. Okay, I guess I'm doing this. Okay, so the pop psychology version of the Dunning-Kruger effect is this. Um, Caleb, if you can get rid of the chat so I can see my chart, that'd be super awesome. On the bottom horizontal axis is competence. On the vertical axis is confidence. So basically on the left side is incompetence. See as you go to the right, you become more of an expert. And there's an obvious notable feature here on the left side of this graph, confidence spikes. I like to think of this as knowing enough to be dangerous. Pop psychology calls this Mount Stupid because you know very little, but you think you know a lot. What ends up happening is as you gain competence, you start realizing, oh, there's more nuance, more breadth, more depth, and your confidence starts sliding down. This is called the Valley of Despair. And then as even more time passes, gain experience, you have lessons learned, then your confidence starts going back up. So if you squint at the scientific paper, this is pretty accurate, but I want to talk about what the actual paper says. Um, so what the paper says, what they did in this paper was they did 4 studies. They did it with students from Cornell University. Uh, so what they did was they picked 4 different areas and they asked the students to self-assess themselves in that area. How good do you think you are in this area? They gave the test. Then they asked them, how good do you think you did? Then they did a comparison. So let's go through a couple of these. The first study was humor. So they picked out some jokes from a couple books. They emailed some professional comedians. They asked the comedians, how funny do you think this is? And then they did the same thing of the students. So the jokes were something like, what is as big as a man but weighs nothing? Punchline is his shadow. No one's laughing because that's not funny, so they'd give that a 1. Another joke, if a kid asks where the rain comes from, I think a cute thing to say is to tell him that God is crying. And if the kid asks why is God crying, another cute thing to tell him is probably because of something he did. Like, we'll laugh. So that is more funny. Good. You guys agree with the comedians there. The graph that this produces is pretty interesting. On the horizontal axis, you have the quartiles, so the worst 25% by the next 25, followed by the next 25%, and so on. The light gray line is the actual test results, which corresponds to the quartiles. The dark solid line is their perceived ability. And there's 3 really notable things about this chart. Number 1, everybody thinks they're above average. This is something we already know about people. If you ask people, if you think they're an above average driver, everyone's going to say for oil. Another thing is the top 25% of the performers slightly underestimated their ability, but more importantly, the bottom 25% grossly underestimated their ability. They said that they were probably in the 60th percentile, which in reality they're like in the 12th percentile. Okay, so they weren't very good at detecting humor. Okay, humor is kind of subjective, but they performed more studies that were a little bit more objective. So they did the LSAT, which is the law school admissions test, and got these results, which is more of a objective domain. And then they did grammar, like the standard for American English, and they got these results, which again, see it's divided out by quartile. Everybody thinks they're above average. Top performers slightly underestimate their ability. Low performers greatly overestimate. So they're able to reproduce this more objective domain. Uh, so they started coming up with predictions, and one of their main predictions here was Uh, Basically, the punchline is it takes competence to recognize competence. So you have to know something about the topic we're talking about in order to know whether you're any good at it. And this data seems to support that. They did a fourth study. Again, it was another logic puzzle, but this time it involved recalibration. So they did something called the Wason selection test. I don't know if Wason is the way to pronounce that. But basically, if cards face up and face down on the table, face up cards can be odd or even. The face down cards can be different colors. And you get a question like, which cards, if any, must be turned over to test the idea that if a card shows an even number on one face, then its opposite face is red. Anyone want to take a guess at the answer here? Makes sense. One. How confident are you? You're wrong. Okay. It's 8 in the brown card. Okay. So graph should not be very surprising. Everyone thinks we're above average and get some sort of miscalibration from the lower performing people. Um, Now the interesting thing here is they wanted to see if this was fixable. So what they did is they asked all the students back, invited them into two groups, said, uh, this group, I want you to just read some material and actually do anything. For this group, I want to give you this packet that teaches you how to solve this logic puzzle correctly. And you get these kinds of results. On the left side, you have the untrained individuals. On the right side, you have the trained individuals. And each column is split up by the quartile again. And you get something. So we're talking about the self ratings of a percentile ability. There's basically no difference with the untrained individuals when they took the test again. But the trained individuals, the low performers, move the needle in the right direction. They realized just, oh, this is actually harder than I thought it was. Uh, so I'm actually going to self-assess my own abilities a little bit lower. Same thing for the perceived test performance. Untrained individuals basically thought they performed the same. Trained individuals again move the needle in the right direction. Same thing for the raw test performance. So this is kind of a quick summary of what happens, but basically what they concluded from this was that in order to fix this miscalibration, how good you think you can do in your own self abilities, to actually education, to actually teach someone how to be more competent. Subject. So I wanted to quickly relate it to how we see this at work. So I was talking to Mix about this the other day. As soon as I learned about this effect everywhere, I see it everywhere in myself as well. So I'm going to give myself as an example. So here's me doing machine vision 4 months ago. Uh, I know nothing about machine vision and very uh, competent. Mark, close your ears for this part, okay? So we have this project where we have an object and we need to teach the machine how to recognize it in 3D. So I start Google searching. I find this called stereoscopic reconstruction. You have two cameras from two different angles looking at the same thing that projects a slightly different image and start trying to figure out how that works in 3 dimensions. So here's me, gaining confidence because I became a little bit more confident. Okay, what's the math on that going to be like? Well, we're searching, do some more research, need the XYZ coordinates derived from these two images. I don't understand where these mathematical formulas came from, but I see multiplication, division, and subtraction. This isn't exactly Diffie-Q, so this is not too bad. So here I am climbing to the peak of Mount Stupid. Uh, so then what happens? I steal Brian's camera. We point some lasers at some objects, and we start doing some experimentation to further our competence. And what happens is the real world hits. Okay, turns out a camera lens is curved, as we all know, but there's radial distortion. As you go further from the center of a image taken by a camera, it becomes even more distorted, which is important when you have two cameras that accurate measurement. You need a camera with a fixed focal length lens, so it can't auto zoom in, auto adjust. I don't know a thing about cameras, so that's awesome. And then as it turns out, you can make measurements on paper and say in theory this should work, but actually build the setup, uh, that gets really hard really fast. So here's me just going like, whoop, this is hard. Maybe we should get more of an out of the box solution. What we I don't actually climb back up the right side of the hill because I knew enough about the topic to abandon that particular strategy. So again, conclusion, there's we see this all the time. You see this in work, you see this in politics, you see this in social conversations. The way to kind of overcome this, to read read articles that agree with you, read articles that disagree with you, engage in conversation, become more competent in the subject, and we can uh, address that time. Exactly. That's all I had. Are there any questions? Yeah. Yeah. So my suggestion, so we kind of did this on our project where we did rapid prototyping to quickly uh, find those lessons learned that we eventually find. So it's just rapid iteration. Yeah, try and overcome that initial confidence. Like that's it. Thanks everyone.